We've built the first infinite energy generator that produces electricity without any moving parts. It generates no noise or heat during operation, and it can power a house. Want to see how we built it? Stay tuned until the end of the video. To begin, we'll use this 3-phase asynchronous motor. It's a 1-horsepower motor with 1,420 revolutions per minute. It operates at 220 volts in a delta connection or 400 volts in a star connection. First, let's open the junction box to check that it's connected in delta. This way, the motor operates on 3-phase current at 220 volts. We can confirm that it's connected as expected. We'll continue by completely disassembling the motor. We remove the 4 bolts that hold the housing together. Using a nylon mallet, we tap the shaft in the front cover to remove it. Next, we remove the rotor along with the rear cover. We won't be using this part. We only need this part of the motor. This part is called the motor stator, and it contains the windings and electrical connections, but we need to connect more wires. So we're going to tap this punched hole so we can put in another cable gland. Next, we'll need 2 microwave transformers like this one. The model doesn't matter, but both must be identical and operate at 220 volts, just like the motor. We must cut the transformer core along these weld lines. We'll use an angle grinder for this. We'll tap it a few times with a mallet and chisel and separate the 2 parts. We'll discard this part of the transformer. Here are the transformer coils. We need to pry them out with a screwdriver. We have to be careful not to damage this coil because it's the one we'll actually need. We've removed it. And now we're going to remove the other 2 coils. It doesn't matter if we break them. We remove the defective coils and clean the transformer core. These are the 2 pieces we'll need. Now we take this countersunk bolt and make some notches in it. These small grooves will allow us to weld it later. We mark the center of the transformer. We place the bolt on the marked center, and we solder it to the transformer's core. We smooth the weld with the grinder, and this is how it looks once welded. We did the same with another identical transformer. We're going to make 2 brackets that will serve as supports for the transformers. And this is how they turned out, one for each transformer. This is the turntable motor from an old microwave. It's a 220-volt synchronous motor. If we apply an electric current, the motor rotates, but also, if we rotate it, it can generate an electric current. With this piece, we can rotate it by hand. With a voltmeter, we'll check the voltage it generates. Yes, we see that it generates 220 volts of alternating current. This motor will serve as the starter for our electric generator. But to adapt it, we first need to connect this power outlet. As you can see, if we connect it to this power strip and turn it, the current it generates illuminates the power switch on the strip. We now have all the materials ready to assemble this generator. We'll use this wooden base, which we've already drilled the necessary holes in. We start by attaching 4 rubber feet. Then we install the motor stator with 4 screws. Now we're going to install the power strip, but first we'll disassemble it to verify that it doesn't conceal any batteries. We secure it to the wooden base with 4 screws. And now we cut the cable to the appropriate length to insert it into the motor's electrical junction box. We also attach 2 electrical connectors. And connect them, one here and the other here. With 2 more screws, we secure this bracket. This is a bar made of a special metal. You can learn more about it in the link you'll find in the video description. We insert it into the stator. Now we'll secure one of the coils to the core of the transformer using these 2 strips of adhesive tape that we've placed there. Next, we attach the transformer to the metal rod, passing it through the bracket. At this point, we can attach the second bracket and the second transformer. We glue the coil back in place and screw the transformer onto the rod. These are the wires that will connect the transformer coils to the motor. We insert them here and connect the 2 blue wires here. And the 2 brown wires here. We close the junction box and connect each wire to its transformer. We wrap electrical tape around the connections to prevent accidental electrical contact. Finally, and most importantly, these powerful microwave magnets will give us the magnetic force necessary for our generator to work. As you can see, these two pairs of magnets attract each other in this position and repel each other in this other one. This is how they should be attached to the transformers. This is how the initial assembly looks. We secure the wires with cable ties, and we finish by attaching the official Liberty engine logo. Remember that our prototypes are not for sale. Don't be fooled by scammers. With the final stickers, our generator will be finished and ready to begin testing. The first free energy generator with no moving parts. It generates 220 volts with a maximum power of 10 kilowatts. No noise, no overheating. We begin testing. Before starting the tests, we showed that there are no hidden wires underneath. With the voltmeter, we demonstrated that there is no voltage coming from an external power source. As you can see, the measurement reads 0 volts. Even when we flip the power strip switch. But now we're going to connect the turntable motor, which will function as a manual starter. We plug it into the power strip and flip the switch. Upon initial rotation, the starter generates an electrical current of 220 volts that powers the motor. At this moment, the motor winding transmits a powerful magnetic field to the transformers through the metal bar. This magnetic field is amplified by the microwave magnets. And thanks to this large, oscillating magnetic field, the microwave transformers generate a current of 220 volts, which feeds the motor winding back in with a power surplus of approximately 10 kilowatts, which is what we use at the power outlets. Let's test this power surplus by connecting, for example, an incandescent light bulb. As we can see, it works perfectly, and the measured voltage remains constant. Without disconnecting the bulb, let's also connect the angle grinder, which consumes 800 watts. You can see that the cable isn't connected to anything else. And when we turn it on, it works without problems. If we disconnect it, it shuts off. This isn't far-fetched, it's pure science. The voltage remains constant even when the power is increased. Let's also connect this fan. We turn it on. And along with the light bulb and the grinder, we see that the generator continues to operate. With this test, we've simulated the energy consumption of a house. The generator consists of 4 parts: the starter, which is the turntable motor, the oscillating magnetic field generator, which is the 3-phase motor, the special metal bar, along with the magnets, which transfer and amplify this magnetic field, and the transformer coils, which generate the electrical current. Remember that you can support the channel by subscribing, becoming a member, or joining our private community. Thank you all for watching this video. Share it so more people can discover that there's another way to understand science.